Hello juniors, today we're going to see electronic assignment 14, which is solving equations using the unit circle. The objectives for today's class are four. First, define cosine and sine of theta in terms of the unit circle. Number two, find the exact values of trigonometric ratios. Number three, apply the Pythagorean identity. And finally, determine the relationship between trigonometric ratios. Okay, so let's start with this challenge exercise. It says, find the value of x if sine of x is equal to 1/2. So in order to solve for x without using a calculator, we need to think about for what angles is sine of x equal to 1/2. If you remember from the hand trick, you would realize that sine of x is equal to 1/2 when x is equal to, for example, 30 degrees, right? If you remember the hand trick, you would see that if you close the 30-degree finger, you would have that sine of x is equal to 1/2. So one possible value is 30 degrees, which if we write as radians, this would be pi over 6, okay? Pi over 6 is 30 degrees. And now my question is this the only possible solution for this problem? And the answer is no. There are other values. For example, in the second quadrant, we have the supplementary angle of 30, which is 150, right? 180 minus 30, that's 150. This would also give me 1/2 as a result. Or if we write it in radians, this is 5 pi over 6, okay? And are these the only two possible solutions? And the answer is no. We can keep on finding, actually there are infinite solutions. For example, if we do 360 plus 30 degrees, we're again in the first quadrant, and this is equal to 390 degrees. And if we find sine of 390 degrees, you would see that again, you would get as a result 1/2, right? Or we can keep on finding values. For example, if we do 150 plus 360, so 360 degrees plus 150 degrees, that's 510. So if you plug in this value, sine of 510, you would also get 1/2. So see that we actually have infinite solutions. If we keep on adding 360, and so on, we will find many other values of x for which the sine of that angle would be equal to 1/2. So this is an important part. It says, in fact, there are an infinite number of values we could substitute for x, so we need more information about the values of x that we are looking for. We need to know two things. Number one, is x measured in degrees or in radians? You see that we had angles in degrees or in radians. So the first thing is x determined in degrees or in radians in a specific exercise? And number two, and the most important, what is the domain? The domain would give us the restricted interval for which we would have 1, 2, 3, or maybe 4 or more answers. According to the domain that we're given, we should determine how many answers we would have. Okay, in this particular example, we didn't have any domain, any restricted domain. That's why we have infinite solutions, right? But we're going to see later on in exercises that we're given a restricted domain that we need to respect. So it says, now suppose we want to solve the equation sine of x equals 1/2, the one we were doing recently, but now we're given a restricted domain from negative 360 degrees to 360 degrees. So there are two positions on the unit circle for which sine of x is equal to 1/2. So we find the angles at those positions which are within our domain, negative 360 and 360. So one possible solution is right here for 30 degrees. A second possible solution will be for 150 degrees. Then a third possible solution could be this negative 330 degrees, which is if we do if we do a complete turn this way, almost 360, but we end up here. So it's 360, actually negative 360 plus 30, and we get negative 330 over here. So that's another possible solution, which is inside our domain, right? 330 is inside this interval over here. And finally, another possible solution would be this one over here, which is negative 210 degrees, which is also inside this interval. So for this particular defined interval or defined domain, we have four possible solutions for sine of x equals 1/2. So the equation has 4 solutions within the given domain, and those solutions are negative 330, negative 210, 30, and 150. Okay, so that's something you need to think about whenever you're solving trigonometric equations. Let's see some examples in order to ground this concept. It says, solve the equation cosine of x equals negative square root of 2 over 2 for this domain from from 0 to 2 pi. 0 to 2 pi is one complete rotation. So we're considering all of the 4 quadrants, right? So the first thing you should notice is that this is a cosine function, right? And we have a negative sign here. So you need to think, for what quadrants is cosine negative? And if you remember from the last class, the unit circle, you would see that the cosine is negative. Cosine is negative for or in quadrants 2 and 3. In quadrant 3. So our answers would be, we would have two answers, one angle in quadrant 2 and one angle in quadrant 3. Okay, so that's the first analysis you should do in order to solve the problem. Okay, so now we're gonna solve the problem. We're gonna think first of all at this value over here. For what value of x is cosine equal to square root of 2 over 2? If you remember from the hand rule, you would remember that a cosine of 45 degrees is equal to positive square root of 2 over 2. So let me write that. Cosine of 45 degrees is equal to positive square root of 2 over 2. Okay, so maybe we should be working with this, something related to this angle. This angle is in first quadrant. So maybe if we find the equivalent angle, but with that gives us a negative value for square root of 2 over 2 in the second quadrant, that will be our first answer, okay? So to do that, we're gonna find the supplementary angle of 45 degrees. So we would say that, okay, let me do this here. 180 minus 45 degrees is equal to 135 degrees. This angle produces negative square root of 2 over 2 for cosine because we're in the second quadrant, okay? So this is one possible solution. But pay attention at something. The domain here is given in radians instead of in degrees. So I need to write my answer in radians, not in degrees. So how do we find that? We can use this same expression. 180 written in radians is pi, right? Minus 45 degrees is half of 90. And if you remember, 90 was pi over 2, right? And if we divide this by 2, we're going to get 45 degrees. So 45 degrees is the same as saying pi over 4. Okay? So this is 45 degrees in radians. So if we subtract this, we're going to get 1 minus 1/4. That's 3 pi over 4. So this is one possible solution. And this is 135 degrees. So we're talking about quadrant 2. This is the answer for quadrant 2. Quadrant number 2. Okay? Then we need to look for the other answer, which is for the third quadrant. In order to find an angle in the third quadrant, remember the rule is 180 plus, in this case, 45 degrees plus 45. So we're going to get as an answer 225 degrees. But once again, remember we need to write this angle in radians because we're given the domain in radians. So, same thing. 180 is the same as saying pi, but now plus 45, which is pi over 4. If we add 1 plus 1/4, that's 5 pi over 4. So 5 pi over 4 would be our second possible result, which is in the third quadrant. Okay? So these are the two solutions to this first trigonometric equation. So when x is equal to 3 pi over 4 and when x is equal to 5 pi over 4, we get this value for cosine, negative square root of 2 over 2. Okay, both of these values are inside this interval. Okay, so I hope you're understanding this, juniors. Let's see the following example. It says, solve the equation. Now we have tangent of x equals square root of 3. And this is our domain from 0 to 720. 720 is 2 full rotations. So we need to consider 2 full rotations in order to find all of the answers. So first thing I notice, we have a positive value, right? Positive square root of 3. So if you remember from the previous class, we saw that tangent is positive in 2 quadrants, in quadrant 1 and in quadrant 3. So since we're doing 2 full rotations, I would have 2 possible answers, Q1 and Q3, 2 possible answers for each rotation. So if I have 2 answers per rotation and I have 2 rotations, that means that I'm going to have 4 answers in total, right? 2 for the first rotation and 2 for the second rotation. So 4 answers is what I should expect. So first answer would be in the first quadrant during the first rotation. If you remember from the hand rule, you should remember that tangent of 60 degrees is equal to square root of 3, right? Because sine of 60 degrees is root 3 over 2 and cosine of 60 degrees is 1/2. If we divide both expressions, we get as a result square root of 3, okay? So tangent of 60 degrees is square root of 3, okay? So one possible answer would be that x must be equal to 60 degrees. And this is inside this interval, and it's our first answer corresponding to the first quadrant, okay? This is one possible solution. Now, a second possible solution must be in the third quadrant. To find an angle in the third quadrant, you know what to do. It's 180 plus this angle here, so plus 60 degrees, and we would get as an answer 240 degrees. So another possible solution of x is x equals 240 degrees, and this is found in the third quadrant. So this is for quadrant 3. Now, I need to consider the second rotation as well. So another possible value of x would be if I do one full rotation, which is 360 degrees, plus 60 degrees, which is our angle that gives us this value over here. So another possible solution is 360 plus 60, which is 420 degrees. So another possible value of x would be 420 degrees. And this is found again in quadrant 1. In quadrant 1, but of the second rotation, right? I'm going to write the declaration here. Second rotation. Second rotation. And finally, our fourth answer would be for 360, the full rotation, plus we need to go to third quadrant, so plus 180 plus 60. This would be our fourth answer. This gives us as a result 600 degrees. That means that x equals 600 is our fourth and last answer. This is found in quadrant 3 of the second rotation. So you see that all of these answers, this and this, are all inside this interval, right? Our first answer is 60, which is greater than 0, and our last answer is 600, which is smaller than 720. So all of the values are inside the given domain, okay? Now let's see the following. It says, solve the equation sine of 2x equals root 2 over 2 for this interval, from 0 to 360 degrees. So we're talking about one full rotation again. So first thing I see is that root 2 over 2 is a positive value. So remember, sine has a positive value in quadrants 1 and 2, right? So sine is positive for first quadrant and second quadrant. So we have one full rotation, 2 possible answers. So we must expect 2 answers. So when was sine equal to root 2 over 2? Sine is equal to root 2 over 2 when the angle when the angle, which is all of this, 2x, is equal to 45 degrees. So sine of 45 degrees is root 2 over 2. If you can remember that from the hand rule, right? That means that the angle, which is 2x must be equal to 45 degrees, right? So here we get that one possible value of x would be that x should be equal to 45 divided by 2, 45 divided by 2, which is equal to 22.5. This would be the first answer, which corresponds to quadrant 1, right? So this is for Q1. But we have a second answer, which corresponds to the second quadrant. So another possible solution would be that would be 180 minus 45 degrees. That's how we find an angle in second quadrant. And this is equal to 135 degrees. So the angle, which is 2x for this exercise, can also be equal to 135. That means that the second possible value of x is 135 divided by 2, which is 67.5 degrees. So this is our second possible value of x, and this one would give us an angle of in the second quadrant. Okay, so these are our two possible solutions for this restricted domain. If the domain was different, maybe we would have more or less answers. Okay, finally, I think this is the last example. We're going to see this one. It says, solve the equation 2 sine squared of x plus 5 sine of x minus 3 equals 0 for this domain from 0 to 2 pi. Okay, so to solve this exercise, let me write the equation first. 2 sine squared of x plus 5 sine of x minus 3 is equal to 0. So in order to be able to solve this, I see that here I have sine squared, here I have only sine, and here I do not have any sine. So I see that maybe if I do a variable change, I will be able to solve this using a factoring case. Okay, so let's do a variable change. I'm going to say that what if sine of x is equal to y, for example. If we rewrite this expression, this would be 2 times y squared plus 5 times y minus 3, and this is equal to 0. And this is a factoring case, right? This is case 6. So if we solve this using case 6, we're going to try not to use calculator. If we apply case 6, we would have that this is 2y squared plus 5 times 2y minus 2 times 3, that's 6, and all of this is being divided by 2. This is equal to 0. So we need to find a pair of values that multiplied would give us negative 6 and that added would give us positive 5. That pair of values would be positive 6 and negative 1, right? Minus 1. So this is all being divided by 2. And finally, if we take out a common factor of 2 from here, we're going to have that this is 2 times y plus 3 times 2y minus 1. This is all equal to 0. This is being divided by 2. And this is equal to 0. So I see that we simplify 2 with 2. So we get two possible values for y. Either y is equal to negative 3, or, let me write that down here, or the other possible value of y would be positive 1/2, right? Positive 1/2. Yes. So we now need to go back to our original variable. Y is defined as sine of x, right? So if we redo our variable change, this means that sine of x is equal to negative 3. Now, for what value of x is sine of x equal to negative 3? This is something very important you should know. Sine, the values of sine will always be between negative 1 and 1. It can never be less than negative 1, and it can never be greater than 1. That's a property that we're going to see later on when we study trigonometric functions, right? But I'm telling you now in order to be able to solve this. Since since sine of x cannot be less than negative 1 nor greater than 1, it means that for this particular equation, we do not have any solution, right? So we're going to say that x has no real solution for this part, right? As sine is always a value in between -1 and 1. Okay, that's the reason we cannot find an answer there. But if we work with this second part, we're going to say that sine of x, which is y, is equal to 1/2. And here we do have a value of x for which sine of x is equal to 1/2. Now let's check the interval. The interval is from 0 to 2 pi. That means that we're considering one full rotation. If we're considering one full rotation, then we should know that sine of x, which has a positive sign here, is going to have two solutions. Let me write it here. Sine is positive for Q1, the first quadrant, and sine is positive in the second quadrant. Okay, so two possible solutions. One solution, which is for the first quadrant, would be sine equals 30 degrees, right? Sine of 30 degrees is equal to 1/2. So sine of 30 degrees is equal to 1/2. So x is equal to, we're given the angle in radians, so we need to write the answer in radians. So 30 degrees, this is in degrees, or if we write this in radians, 30 degrees is pi over 6. So this would be one possible result. I'm only framing the angle which is in radians because our domain is given in radians. Okay, so this is the answer. This is the answer for Q1. Now, the second answer, which corresponds to the second quadrant, would be x is equal to 180 minus 30, and this is 150 degrees. So the other possible answer is 150 degrees. Let me do this in radians before. So this is the same as saying pi minus pi over 6, right? 180 minus 30. So we get the second value, which is x equals pi minus pi over 6, that's 5 pi over 6. So this is the second answer, which corresponds to the second quadrant. This is quadrant number 2. Okay, so just to clarify, this is x1, and this is x2. Okay, so that's how we solve trigonometric values. We should always consider the domain of the exercise in order to see how many results we would have. Because if we do not have the domain defined or restricted, we should have infinite solutions. Okay, so that's it. I hope this was clear, juniors. If not, please let me know. We're going to clear doubts in future live sessions. Thank you for your attention and see you.